Hey everyone, welcome back to another Kubernetes tutorial. Today we are going to learn something super useful, how to keep pod running in Kubernetes using Sleep Infinity. We will understand why we need it, who it's useful for, and then I will show you the simple hands-on demo step by step. So let's get started. Why to keep a pod running with Sleep Infinity? Let's understand the problem. When you create a pod using a simple Ubuntu image, the container starts and does nothing and immediately exits. Because there is no program running inside Ubuntu by default, Kubernetes sees that the container has finished and moved the pod to complete state. But sometimes you don't want it to exit immediately. For example, you want to exit into a pod, meaning open a shell inside and explore, or you need to test environment to practice Linux commands, or you are building or testing the image and need time to inspect them, or you just want a pod always ready for quick experiment. Without Sleep Infinity, the container process might complete quickly and the pod will exit, making it unavailable for your needs. That's why we use Sleep Infinity. It keeps the container sleeping forever and pods stay running without doing anything heavy. Who is this useful for? This trick is super useful for a beginners learning a Kubernetes topic, developer needing a lightweight Linux container, system administrator troubleshooting the issue, or anyone want to practice Linux inside the Kubernetes. When I say exec into a pod, I mean starting a shell session inside the running container. Alright, let's start with a small demo. I will create a simple pod without Sleep Infinity. Let's create a YAML file, ubuntu-pod.yaml. Let's add API version v1, kind pod, and metadata. I will give Ubuntu as a pod, Ubuntu-pod, spec, I will create a containers, give name Ubuntu, provide the image Ubuntu, and I will add the command. This is a simple command. For testing I am using this. I will give the bash as a shell, give the -c, comma, give the command hello world, save and exit. So we have created the YAML file. I will show you the content. Now let's apply the YAML file by using kubectl apply -f followed by the YAML file. So we have some issue with the YAML file. Let's cross verify. Kind pod pcapital. Let's save it. Rerun the command. You can see the pod has been created. Now let's run the command kubectl get pod to check the pod status. CrashLoopBackOff. You will notice the pod goes into CrashLoopBackOff. Let me quickly explain why this happened. When you create the pod, it simply run echo hello world, which finish instantly and exit. If it exit normally, Kubernetes may show the pod as completed. But if the pod's restart policy is always, which is default for pods, Kubernetes tries to restart it, causing a crash loopback off because there is no ongoing process to keep it alive. This behavior is expected, and it highlights why we need a dummy long running command like sleep infinity to keep the container alive. You can also describe the pod for more details. Run kubectl, describe, and provide the pod name. Typo mistake. Kubectl describe pod followed by the pod name. Let's scroll up. Under containers, you can see the last state is terminated with reason completed and exit code is 0. That means our container successfully ran the echo hello world command and then exited immediately. And here you can see the state. It shows waiting, and the reason it shows crash loopback off. Because the pod restart policy is set to always by default, Kubernetes keeps trying to restart the container, but since the echo hello world command finished immediately and there is no ongoing process, it keeps failing and goes into crash loopback off state. And also we can see the event section. Scroll down. These are the event section. Here you can see successfully pulled the image, no issue with the image. Started the container Ubuntu, and here you can see back of restarting failed container Ubuntu. You can also see it clearly shows in the event section. First, Kubernetes started the container successfully, but because the container exited instantly after printing hello world, Kubernetes kept trying it. Since it fails to stay running, it eventually leads to a back of restarting failed container error. So overall it's behaving exactly as expected. The pod runs, finish the echo command, exit, and Kubernetes keep trying because there is no ongoing process on the container. In short, the container runs successfully, exit code is 0, but exited immediately because there was nothing left to do. Kubernetes then keeps trying to restart it, leading to crash loopback off. This behavior is normal for short-lived command. Please make a note, if you ever see crash loopback off in your pods, don't panic immediately. Always check if the container simply exited after completing a quick task. Sometimes it's not an error, it's just how Kubernetes behave with short-lived commands. And this is why we need to run a dummy command like sleep infinity to keep the container alive. Without it, Kubernetes assumes that the container job is done and mark it completed. To fix this YAML with sleep infinity, we need to delete the pod first. Kubectl delete pod ubuntu -pod. Like this also you can delete, or let me show you the two-way. Kubectl apply -y ubuntu YAML -f. It's a typo. I have recreated once again. The other way to delete is kubectl delete. Instead of apply, I am using delete -f ubuntu -pod. It will delete it. To cross check, you can run kubectl get pods. Ubuntu -pod is not available now. It has been deleted. So we have deleted the pod. Now let's update the YAML file. So here we need to update the command. Instead of this basic command, I will update with infinity command. Sleep in double quote mention infinity ty infinity. Okay, save it. Reapply the YAML file by running the same command kubectl apply -f ubuntu pod.yaml. Pod has been created. So check the status again. kubectl get pods. Here you can see now the status of the pod is running. Exactly what we wanted. So let's explore the pod using exec command. kubectl exec-it. I will give the pod name. You can directly copy paste this and give the bash. Enter. I forgot hyphen. So now we are in the container Ubuntu pod. IT means interactive mode. --bash opens a bash shell inside a container. Now you are inside your Ubuntu container running inside the Kubernetes. Try some command, Linux command like ls run pwd or uname -a, and also you can check. This is my Rocky Linux. Now we are in the pod container. We can check the OS. Are we using Ubuntu or not? Here you can see we are using Ubuntu 24, the latest version. Explore freely, and if you want to exit, you can exit with exit command to exit from the container bash shell. If anything goes wrong, two helpful commands are you can check the logs. kubectl logs, give the Ubuntu -pod. If the pod has just started and completed the echo command, which finished quickly, it might not have produced any log. The command might have been too short-lived to generate a meaningful logs. If you want to check kubectl get pods, the troubleshooting first command is like we can check the logs of the container. I will run kubectl log of other container. Like this you will get the logs, but currently Ubuntu -pod has not generated any logs, so we are getting a blank output. And the next command for troubleshooting is kubectl describe, provide the pod, and Ubuntu provide the pod name. These help a lot with troubleshooting or learning. Quick refresher about pod lifecycle stage. Pending means pod is getting ready. Running means pod is alive and container is active. Succeed or failed if the container finish or crash. By using sleep infinity, we ensure the pod stay in running phase as long as we need. Let's take an example. Imagine you are learning Linux and you also want to get comfortable with Kubernetes. Instead of setting up a separate VM, you can simply launch an Ubuntu pod inside your Kubernetes cluster with a sleep infinity. Now you can exec into it and practice Linux command just like a real server. Super fast, lightweight, and no extra installation needed. If you want a quick one-liner command and you don't want to create a YAML file, you can instantly do it with a single command. I will share the single command kubectl run. I will give the pod name. Ubuntu pod we are already using. I will give pod 1 -image Ubuntu. I will run command sleep infinity something command I am not remembering. image hyphen open equals to. Okay, pod is created. kubectl get pods. Here you can see we just now created Ubuntu Pod 1. It's running since 6 seconds. Like this, you can create a pod without using YAML file if you want to practice Linux. Instantly launches a pod that stay alive forever. Great for quick testing. How to delete the pod? I have already shown you. kubectl delete pod and give the pod name. When you are finished practicing, remember to clean up. This keeps your cluster clean and save the resource. Here I can give pod 1. This will delete the pod. Sometimes if you exec into the pod too quickly after creating it, you might see an error like container not found. Just wait 5 to 10 seconds for the pod to fully initialize and then try again. Why this is taking time to delete? Okay, it has been deleted. You are not limited to just Ubuntu. You can try Alpine, very small Linux image, or you can try CentOS, which is Red Hat based environment. Let's see the command. If you want to try Alpine, kubectl, the command will be same. Here I will give Alpine pod, update the image name, and the rest is the same. Enter. The pod is been created. kubectl get pods. Here you can see the container is running. If you want to try CentOS, which is Red Hat based environment, you can run the same command. Just update the image. CentOS the pod has been created. kubectl get pods. This has been error image pull. I think we need to provide some version. Let me quickly run some other pods. Let me delete it first. kubectl delete pod. CentOS is not working. If you get error like this, error image pull, just check it on a Docker Hub if the image is available or not. If not, you need to provide the version. Let's try if it is running or not, or else we will check it on Docker Hub. It's running CentOS pod. It is in running state. This is a great way to get familiar with multiple Linux flavors right from the Kubernetes. Let's quickly recap. Sleep Infinity keeps your pod alive forever. Very helpful for beginners, admins and developer. Practice Linux command easily inside the Kubernetes. Clean up after your experiments. Try different Linux OS images to learn more. And that's it for today's tutorial. I hope you found this helpful, simple and easy to follow. Please like, subscribe and share it with others learning Kubernetes. Thanks for watching and I will see you in the next tutorial.